Okay, this is a continuation of exponential equations, and I'm on page 3, and we're going to look at bullet number 7. Exponential equations, equations that are of the form y is equal to a to the x. If you have a to the u power, and that's equal to a to the v power, so notice that the two bases are exactly the same, then you can make an equation with the exponents. Then u is equal to v. So we're going to be rewriting all of the bases so that they are the same. So to solve exponential equations, you want to get the same base, then you want to make an equation with the exponents. Okay, you get the same base and then make an equation with the exponents. Okay, so let's do a few examples with this. So for the first problem, you have 5 raised to the power of 1 minus 2x is equal to 1/5. So I'm going to get both of them to be a base of 5. So this one is already in the base of 5, so I'll just keep it as it is. And then to get 1/5 as a base of 5, I'll write it as 5 raised to the negative 1 power. Right? So notice that this base and this base is exactly the same. So that means that I can make an equation now with the powers. So I would just take away the base, and then it's 1 minus 2x is equal to negative 1. And then I just solve this. So negative 2x is equal to negative 2. So x is equal to 1. Okay, for b, I have 4 raised to the x squared is equal to 2x, or 2 to the x. So I'm going to make both of them so that it has a base of 2. Usually, if you have a choice, you want to make it so that you'll use the smaller one as the base. So I'm going to rewrite 4 as 2 to the second power, and then I'm raising it to the x squared, and the right side I just keep by itself and I don't change anything. And then when you take a power to a power, that multiplies it. So this becomes 2 raised to the 2x squared, and then is equal to x, or 2 to the x. So now, since the bases are exactly the same, I can make the powers equal. So it's 2x squared is equal to x. Now don't divide by 2 on this. You want to bring over the x, factor out an x. So that'll be 2x minus 1 is equal to 0. And then solve for x. So x is equal to 0 and also a half. Okay, make sure you don't divide by 2 here, or else you'll lose out on the answer for 0. Okay, for C, I'm going to rewrite it with a base of 3 for both of them. So it's 3 to the second power, and then raise it to the negative x, and 3 to the negative 1. And then it's 3 raised to the negative 2x because you're multiplying. And then this one I'll just keep as 3 to the negative 1. So the base again is the same on this. So I'll just make an equation with my exponents. So that becomes a negative 2x is equal to negative 1. So x is equal to a half. Okay, one more. I'm going to change 4 to 2 to the second power, and then raise it to the x, minus 2 to the x is equal to 0. So this becomes 2 to the 2x, and I'm just going to bring the 2 to the x on the other side. And so your bases of 2's are the same, so I'll make an equation with my exponents of 2x is equal to x. So then x is going to equal 0. Okay, I'd like you to turn off the video and try the next 2 problems on the next page. So that's on page 4, try E and F, and then come back and check your answers. Okay, so please check your answers for E. It's I'm going to rewrite 3 as, or just keep 3 to the x as 3 to the x. And for 27, I'll rewrite it as 3 to the third and then raised to the negative x power. And then I'll rewrite 9 as 3 to the second and then raised to the x power. Okay, so I'm going to now apply my rules for exponents. So 3 to the x will just stay. This will become 3 to the negative 3x, and this will become 3 to the 2x. Now, I don't want to uh, just set my exponents equal at this point. I'm going to combine these. So remember, when you multiply, you're going to add the exponents. So this will become 3 raised to the x minus 3x. And then on this side, just keep it the same. At this point, I can make an equation of my exponents. So that will be a negative 2x. I just combined that is equal to 2x. So 0 is equal to 4x, so x is equal to 0. Okay, for the next one, I'm going to rewrite e to the 4 raised to the x as e to the 4x. And then e to the x squared, I'll just keep it as it is. And that's equal to e to the 12. So I'll combine this as 1 base of e. So I add these two together. So that's e raised to the x squared plus 4x is equal to e to the 12th. And now I'll take away the e's and then just set the exponents equal to each other. So that's x squared plus 4x is equal to 12. And then I set that equal to 0. So x squared plus 4x minus 12 is equal to 0. And then I factor it. So the factors are x plus 6 and x minus 2, and that is equal to 0. And so then x is equal to negative 6 and 2. Okay, the next are two application problems. So the first is the healing of the wounds. The normal healing of wounds can be modeled by an exponential function. If a sub 0 represents the original area of the wound, and if a represents the area of the wound after n days, then the function a sub n is equal to a sub 0 e raised to the negative 0.35n describes the area of the wound on the nth day following an injury when no infection is present to retard the healing. Suppose that a wound initially had an area of 100 square millimeters. So the first part is, if healing is taking place, how large should the area of the wound be after 3 days? So I'm going to write down that the initial area of the wound is a sub 0 is equal to 100. And then I take this equation that's given, and in place of the a sub 0, I'm going to put in 100. So I have a of n is equal to 100 e raised to the negative 0.35n. And then I'm going to look at it for 3 days, so that will be the time. So it's a sub 3 is equal to 100 e raised to the negative 0.35 times 3. Right, so I'm just putting in 3 for the n. And then I just use my calculator and punch that in, and I end up with 34.994 square millimeters. So that will be the area of the wound after 3 days. Okay, so how large should it be after 10 days? Same sort of problem, except now I'll just put in 10 in for n and solve that. So it's 100 e raised to the negative 0.35 times 10. And so after 10 days, it'll be 3.020 square millimeters. All right, the last problem is on spreading of rumors. A model for the number of people n in a community college who have heard a certain rumor is given by this equation here. N is equal to P quantity 1 minus E raised to the negative 0.15D, where P is the total population of the community, and then D is the number of days that have elapsed since the rumor began. In a community of 100 students, how many students will have heard the rumor after 3 days? Okay, so I'm first going to start off by writing P is equal to 100. So that's the total population, which is 100 students. And then I'm going to put it back into this equation right here. So it's the number of people who have heard the rumor after D days. All right, so N represents the number of people in the community who have heard the rumor, and D represents the number of days. So the 100 will be the P, and then I write out 1 minus E raised to the negative 0.15 D. All right, so then in place of the D, which is the number of days, I'm going to put in 3. So it's N of 3 is equal to 100 quantity, 1 minus E raised to the negative 0.15 times 3. And then put this into the calculator, and you get 36 students. So after 3 days, 36 students will have heard the rumor.